Now we are discussing about flow control in TCP, Transmission Control Protocol. As we discussed already, TCP is required for reliable internet. Flow control and error control, generally they will come under the data link layer sections. Now we are discussing the flow control in Transmission Control Protocol. Whenever we are sending the data from the source to destination, after the destination receives the data, it will send the acknowledgement. So the source will wait for the acknowledgement. Until the acknowledgement it will send. When the destination is sending the acknowledgement, it has to stop the transmission. But what actually destination is doing? After receiving this data, because I am talking about the data in the data link layer, the data is in frames. Now the frames are being sent from source to destination. Definitely when the network side, when they are coming in the form of the packets. Now the packets are nothing but a group of frames. They have been divided. Now the frames are being transmitted from source to destination. Destination received these frames. But after receiving, before the use, destination will check whether there is any error in it, whether correctly received or not. This is called processing. So destination will perform the processing. But this transmission of the frames and processing of the frames, they are not with the same speed. These frames, when they are coming from the source to destination, the processing time is always higher than the transmission time. Because the processing time is always higher than the transmission time, the bits are transmitting. But these transmitted bits have to wait, because already previously transmitted bits are still in processing. So for that waiting, we require a buffer at the receiver. Transmission speed is higher than the processing speed. The time takes for the transmission of the frame is lesser, and the time takes for the processing is higher. Because the processing time is higher, the transmitting frames, they have to wait. They are waiting in buffer. When the buffer fills, then the receiver sends an acknowledgement saying that stop transmitting. When buffer filled, then only it will send the halt acknowledgement. So here we are using sliding window protocol for the flow control. In this, from the source we are sending the multiple frames at a time. We are not sending single frame. In sliding window, we are sending multiple frames at a time. So multiple frames we are at a time, but the receiver sends only one acknowledgement frame. From the source we are sending the multiple frames. From the receiver we are sending only one acknowledgement. Buffer is filled here in this case. But now we will introduce the new term called window. Sliding window. We will. So what is this sliding window? This is an imaginary window. This is an imaginary window. This window size changes. That's why we are calling this as a sliding. Like we are moving our window. Your bus seat window or car window or your home window. You are sliding window. If I am sliding this board, that is called a sliding board. Similarly, this is like, I am sliding this chalk piece. This is sliding chalk piece. Similarly, we are sliding the window. When we are sliding the window, it appears like the window is sliding. So its length is changing. Its length is shrinking or its length is expanding. That's what we call as sliding window. Now when we are again we are saying it is an imaginary window. There is no such window in our transmission layer. It is an imaginary window. So in which we are taking the boxes which are also imaginary. Imaginary boxes we have taken. So these imaginary boxes, they hold the sending and receiving frames. One sliding window at the sender place, one sliding window at the receiver place. Example, sender is sending these 7 frames. Okay, sender sent 1 frame. Then how many frames are there? 6 frames. Now the window size is decreased to 6. Now the sender sent 2 frames. First it will send 0 and 1. Example, sender sent 2 frames. Okay, these 2 frames it sent. How many frames still left? 5 frames. What is happening to the window size? Decreasing. At the receiving side, what is happening to the window side? Expanding. Okay, so it is shrinking at the sending side. At the receiving side, window size is increasing. If I say at the receiving side window size is 2, that means at the sending side the window size is 5. If at the receiving side the window size is 3, at the sending side the window size is 4. Provided if I am taking the window as a window size as 7. Okay, we are calling this as a modulo. We are taking, if the example 8 means 0 to 1, 2 and so on 7 we can start. Here the window size is 8. Here the window size is 8. If 2 frames are received at the receiving side, then what is the window size at the receiving side? 2. What is the window size at the transmission side, source side? 6. If 3 frames are received by the receiver, what is the window size, sliding window size at the receiving side? 3. What is the sliding window size at the transmission side, source side? 5. So these 2 numbers should match when we add the window size of the transmitting source side and the receiving end side. That should match to the window size. Now we will see. There is an upper limit for transmitting the frames. What is the upper limit here? 8. After the 8 frames are sent, here the buffer is filled. Now it will send an acknowledgement. How many frames acknowledgement? Single frame acknowledgement. Halt the transmission. When it is sending the halt to the transmission, along with it, it will send how many frames it has to send during the next time. That also we will discuss here. Okay, window size, as just now we discussed. Frames acknowledgement by the receiver, not full. Even example, in one case, receiver is not full. Receiver is not full. But example, in some cases, we are sending packets with the 5 frames only. 5 frames we have sent here. Receiver is not full. But still it will send an acknowledgement saying that frames I have received. Next it will start the next transmission. And a transmitter will send also frames. Transmitter may send also acknowledgement even when it is not full. Transmitter will not send acknowledgement. The transmitter will send the frames even when it is not full. There is no requirement that a transmitter should start sending the frames when it is filled completely. Even when it is half filled, it can start sending. Even when it is half filled, it can start sending. When it is half filled, example 1, 2, 3, 4 filled. Here it is 1, 2, 3, 4 came. Remaining frames are there, 5, 6, 7. But here previous frames are there. Those previous frames are utilized. But in this case, even though it is not full, the receiver may send acknowledgement saying that stop the transmission, or halt the transmission, or I have received the 4 frames. We are saying this as an optional case. In generally, acknowledgement we will send only after receiving all the number of the frames. That is the normal case. But there is no mandate that you have to send acknowledgement after receiving all the frames. Example, after you receive 3 frames, you can send acknowledgement. After you receive 5 frames, you can send acknowledgement. After you receive 8 frames, you can send acknowledgement. You can send n number of the acknowledgements. But each acknowledgement must be 1 frame. You can send acknowledgement even when the receiver is not full. But this is not a compulsory case. This is an optional case. Example, I want to send an acknowledgement after receiving 4 frames, saying that I have received 4 frames, send me remaining 4 frames. I have received 5 frames, send me remaining 3 frames. And the second case we are discussing, the source can transmit the frames even when it is not full. When 3 frames came here, immediately it can start transmitting. There is no need to wait for the remaining frames. The sliding window should not be filled in transmission case. Even though the sliding window is not filled, the incoming frames immediately it can transmit. But at the receiving side, because it has to process, they will wait in the buffer. So when we have to send acknowledgement, generally in most probable cases we will send acknowledgement after the buffer is filled or the sliding window is filled. But we can send the acknowledgement even before the sliding window is filled. Even when you are receiving 4 frames, you can send the acknowledgement. This is an optional case. This is what we discussed about the flow control in TCP. In transmission control protocol, we are controlling the frames. How many frames should be sent from the source to destination? And after sending how many frames, we have to send acknowledgement. Why we require acknowledgement? If acknowledgement is sent, then only the transmitter can understand how many frames I have to send. The main reason we have discussed, the processing speed at the receiving side is not same as the transmission speed at the transmission side. In order to make sure that the transmission bits wait for some amount of time until the processing is completed, we are making sure that we are using the buffer. In these buffer, the transmitting bits, which we are calling in the data link layer frames, these transmitting frames are stored. Once the transmitting frames are completed, filled, then it sends the acknowledgement. We are saying there is no mandate that only one acknowledgement can be sent after filling the frames. In between also you can send the acknowledgement when the buffer is not full. But it is mandatory to send the acknowledgement after the buffer is filled in order to sender to know, stop the transmission for some amount of time, halt the transmission for some amount of time. So we have discussed in the data link layer. Because we are discussing in the data link layer, we are discussing in the format of the frames. Because we are discussing in the data link layer, these two terminologies, flow control and error control. Error control we already discussed. Here we are discussing about the flow control. In the flow control, definitely we are discussing the flow from the source to destination. We are sending the frames. The source is sending the frames. How many number of frames it is receiving, immediately it is sending. It is not waiting for all the frames I have to receive. Whatever the frames it is receiving, immediately sending. Now we have discussed about sliding window protocol. Sliding window means there is no such window in the data link layer we discussed. It is an imaginary window which is having some boxes. So here, if we are taking a window of modulo n, that means in source side n and destination side n. Example, n is equal to 8, n is equal to 8. So 8 means 0 to 7. 7 windows. 7 plus 1, 8 windows we have taken. Sliding window. If we are sending one frame from the source side, then the window size reduces to 7. Then the receiver is receiving 1 frame. If we are sending 2 frames, it reduces to 6. And the receiving side, it expands to 2. At this time also we can send an acknowledgement to sender saying that I have received 2 frames. Third frame we have sent. It shrunk to 5. It expanded to 3. 4 frames we have sent. It shrunk to 4. It expanded to 4. At this time again we can send an acknowledgement. I have received 4 frames. Next we are sending 5th. Next we are sending 6th, 7th, 8th. Then it tells stop. I need some time because buffer is already full. Processing is completed. Then you can transmit. Okay. This is how the flow control work in transmission control protocol.